This video is the second part of the videos on how to price options, and in this video I will show how to calculate the price of an option using an alternative formula and how to calculate the delta of an option. Now, we've seen in part 1 that the basic formulas to calculate the price of an option are these two. D1 and D2 are not necessary because we're not going to be asked to calculate them in this exam, so we can forget about it. So we're left with these two equations. Before we introduce the put-call formula, I want to remind you of the letters, so the math symbols that are used here. S0 is the price of the stock today. K is the price of the stock if you use the option to buy it. So we have here two stock prices, if you want. One that is the stock price in the stock exchange, so S0, and particularly today, and K is the stock price that you will have to pay if you use the option to buy the stock. R is the interest rate or risk-free rate, and T is the time to maturity of the option in years. Now, as I said in part 1, years here is important because T is not in months. However, options have an expiry date every 3 months. So this means that all the data you have regarding an option will be given in months, and you have to convert the month into years. Now, this is the formula of the put-call parity, and you can see straight away that it is related to the Black-Scholes formulas, because you see some symbols that are common. So S0, K, R, and T are the ones we've seen previously, so I don't need to re-explain it. The only difference here is that we have D, and D is the dividend. Of course, stock, which is a share, will pay dividends. Yeah. And if your option lifetime has a dividend paying date during the lifetime, then you have to adjust the price of the put and the call to take that into account. Now, it's very simple to add dividend here. You just it's given to you, so you don't have to worry about that. The other thing that you need to keep in mind is that C is the price of the call and P is the price of the put, but this is a standard symbol for put and call, and it will give, one of them will be given to you, the other one is the one you have to calculate. Example. You're given this question, so you have the current price of a non-dividend paying stock, which is £19. The price of a 3 months European call option with a strike price of £22 is worth £1, so it's the option that's worth £1. The risk-free rate is 4% per year, and you're asked to find the price of a 3 months European put option with a strike price of 22. This is the formula you see in the exam paper, and you can see that the numbering is 19. In the video part 1 I said that 19 was P and 20 was C, but I've just checked that in fact P is 21 and C is 20, so you have 19, 20, 21, but it doesn't really matter because you will recognize the formula when you see it. So if you put everything together, you have the question and you have the formula. Before you answer it, what you need to do is match these words with the formula, because you see here you have no P, no C, no S0, no D, no K, nothing. You have to match them. So that's what we do here. Now, I've written on the right hand side the words that are important in the question. So it says first that the current stock price is 19. Now, we've seen that S0 is the stock today, so current is today. This means that we have S0 is 19. The risk-free rate is 4% per year, so we have R equals 4%, 0.04. The price of a 3-month European call option with a strike price of 22 is 1. So 3-month call. Now call means C, and the price of the option is 1. Now you may say that the only thing that matters in the whole of this is only C equals 1. Why do we need the rest? Because the put-call parity only works if you have a call and a put that have exactly the same strike price, exactly the same maturity. Otherwise you cannot use it, which is why I insist on keeping here 3-month European call with a strike price of 22. And when you look at the put, it's described as a 3-month European put of a non-dividend paying stock, a FIN. Okay, so it's the put here, so that's what you're looking for. P, you don't know what it is, with a strike price of 22. So they have the same strike price. And this is the main condition for using the put-call parity. They must be exactly the same, except that one is a call option, the other one is a put option. Now, solving the question, first you take your formula. So this is the one given in the exam paper, and you rewrite it to put the price you're looking for on the left-hand side of the equal sign. If you were looking for C, so if the question was calculate the price of a call instead of calculate the price of a put, you will rewrite this writing C equals, so P plus S0 minus D minus K, right? Because what you're looking for is C, but in our question you're looking for P, so you don't need that. Now all you have to do is plug in the values. So we have seen that C, the price of the call, is 1. D is 0 because there's no dividend. Yeah, so if you want reread the question, it says a non-dividend paying stock. Non-dividend means dividend is 0. Your strike price was 22. I was going to write 19 here, but it's 22. R was 4%, so 0.04. T, remember, T is in years, so it's 3 divided by 12, a 3-month option, and S0 is 19. So that's the one, that's 19. Now, if we plug in everything, you get plus 0, so let's put everything as it is. 4 times 3 over 12 minus 19. So we have 1 plus 22. The exponential expression is, in fact, if everything multiplied, is 22.781096 minus 19. So it gives you a put price of 3.781019, which is 3.78 pounds. Now remember, to avoid mistakes at the end, always keep at least 6 decimal points. You can see here 2, 4, 6 when you're doing the calculations. Do not round up before the end. If you have, for example, zeros, yeah, after 3 decimal points, obviously you cut at after 3 decimal points because 0 doesn't count. But if you have any number that is not 0, you have to keep all these numbers. You could say I could cut here, yeah, but because there's a 0 here. No, you have 9 after, so you have to keep the 0, 9, 6. The only situation where you would cut is that if you have, for example, 22, 7, 8, 1 and then 0, 0, 0, 0, then the only relevant number is this one. Yeah, the rest doesn't count. But as long as you have decimal numbers that are different from 0, you have to keep at least 6 of them. Okay, otherwise you will have mistakes in your final numbers. Question on delta is very, very easy. So you have it written here, and it's very simple. What is the delta of a European call option on silver? You have a lot of other stuff here that is essentially confusing, if you want, because it's completely unnecessary. The only thing you need to know is that the option matures in 8 months and the risk-free rate is 12%. Now, why don't you need the current price of the silver, etc.? Because delta has no current price of anything. You see, the only thing you need for delta is the risk-free rate, the maturity, and the normal distribution value for D1, which is given to you. So I've put in red here the only information that you need to calculate the delta. Yeah, all you have to do is plug in. So delta will be equal to exponential of minus 0.12 times, so 8 months, in years it's 8 divided by 12, and you multiply by n d1, which is 93. Now I wrote exp here because e minus rt can also be written as exponential of minus rt. Yeah, so delta is equal to 0.923116 times 0.5293. So delta is 0.488605. Now this can be rounded up as 0.49. Yeah, but until you get to the end, you have to keep at least 6 decimal points to make sure you don't have rounding errors at the end. That's it for option pricing.